All right, so moving on to 7.3, we're going to use this process called Gaussian elimination to solve linear systems. And what is Gaussian elimination? If you take a look, right, it's using elementary row operations and to solve linear systems. And the final system has to be in this form called row echelon form, or we can abbreviate, we'll call it REF. Okay, so this begs the question, what is elementary row operation? So you can take a look for yourself, right? You can interchange any two rows, multiply any row by a constant, and add and subtract any rows, any two rows. So over here, right, when you place your system of three equations, three unknowns, this is the x column. The first column is the x column. The second column is the y column. The third column is the z column. And these guys right here are just constants. When you look at something across, like horizontally, these guys are called rows. So row 1, row 2, row 3. And this last column right here is the constant column, okay? So what is row echelon form? Well, row echelon form is, it basically has to have these two characteristics met, okay? Each leading coefficient has zeros below it, and each leading coefficient is to the right of each leading coefficient above it. So take a look at my system of three equations, right? Notice it's in this particular order of columns, right? The first column is the x column, the second column is the y column, the third column is the z column. This last column right here, right, is the constants, okay? And so I want to show you what a row echelon form looks like. So take a look, right? Each leading coefficient. So this leading coefficient right here is a 1. This leading coefficient is a 2. And it has zeros below it, right? There's actually no numbers. But basically, if there's no numbers, right, we just put zeros underneath. So characteristic number 1 is met. Now, what about 1? Is there a 0 below it? Well, there's no equation. So this last example, or this last row, it still meets the definition of REF. The second characteristic requirement that must be met is that each leading coefficient is to the right of each leading coefficient above it. So this first equation right here, right, of 1x, the 1 right here is the leading coefficient. It doesn't really have anything above it, so that doesn't really matter. But really what you want to do is take a look at these last two rows. Notice this 2 right here is to the right of this 1. And notice this 1z right here is equal to 1. This 1 is to the right of this 2. And so I kind of just highlighted right here, or not highlighted, but I circled. It kind of looks like a I guess a slope or line that has a negative slope that kind of cuts through, slanted, I guess, in a way, if you want to visualize it, if you're a visual learner. That's kind of what it looks like at the end. And the reason why you want to put it in this form, as you'll see as we do the examples, it's easier to solve, okay? So here's another example of row echelon form, right? Each leading coefficient has zeros below it. Each leading coefficient, let's say this 1y right here, is to the right of 2. This 3 is to the right of 1. Okay, so again, it kind of looks like that downward slanted line with a negative slope. Okay, so that's kind of how to visualize it in the big picture. All right, so, I mean, these terms right here, row echelon form, Gaussian elimination, it sounds very complicated, but when I actually do the examples, it's not that difficult if you use correct notation, okay? And make sure you don't make, silly mistakes with just, computation, which often happens. So let's take a look. It says solve using Gaussian elimination. The final form must be in row echelon form. Okay, so again, I know what you're probably thinking. The technique I'm showing you seems a little more complicated than what you learned in the past, but it's important that you learn the technique because later on, if we do get into matrices, you do have to know what row reduced echelon form is, and it's just kind of helpful to learn another technique. All right, so in order for me to put this in row echelon form, right, I need to take the second row right here and basically make it such that it doesn't have this x minus 2y. So I have to get rid of this x in the second equation. So the way I'm going to get rid of it, right, is we can add and subtract any two rows. So I'm going to write row 1 minus row 2, okay? So again, I'm going to copy down the first equation, x plus y plus z is equal to 3. And I have x minus, this is the part I want to replace, so I'm going to erase this. So after I do row 1 minus row 2, I'm going to replace replace the new equation in row 2. Okay, so x minus x is 0. Y minus negative 2y is 3y. Z minus 4z is negative 3z. And 3 minus 5, of course, is equal to negative 2. Okay, and then you bring down the other equation again. All right, so the next thing I want to do, right, is take a look at this last equation, 3y plus 4z is equal to 5. And I want to get rid of this 3y. And that way my 4 can be to the right of this 3 in row number 2. Okay, so the way I get rid of that, right, is you can simply subtract row 3 from row 2. So I'm going to write row 2 minus row 3. Again, write the first equation again, x plus y plus z is equal to 3. And write down the second equation, 3y minus 3z is equal to negative 2. And I simply replace this result, okay, r2 minus r3. 3y minus 3y is 0. Negative 3z minus 4z is negative 7z. And negative 2 minus 5 is negative 7. Okay, so this is now in REF form. Row echelon form, right? So what's row echelon form? Let's double check, right? Each leading coefficient, this 1 right here has zeros below it. This 3 right here has zeros below it. Okay, so I'm good with that. And then notice this 3 right here is to the right of this 1. This negative 7 is to the right of this 3. Okay, so that's characteristic number 2. Each leading coefficient needs to be to the right of each leading coefficient above it. And so what's so special about this form, right, is now you can solve, right? So, negative 7z is equal to negative 7. You're going to get z is equal to 1, and then you just back solve into the second equation. So 3y minus 3 times 1 is equal to negative 2. So negative 2 plus 3 is 1. You're going to get y is equal to 1/3. And then you need to solve for x, right? X plus 1/3 plus 1 is equal to 3. If you solve, you're going to get 2 minus 2/3, which will give you 5/3. Okay, so your final answer will yield 5/3, 1/3, and what just happened here? Sorry about that. 5/3. X is equal to 5/3. So 5/3, 1/3, and 1. All right, let's move on to the second example in case that first example did not make a ton of sense. This time, I have a little bit more. I guess I have 3 equations, 3 unknowns, such that every single row and column has a constant. Unlike this first problem, right, the third equation did not have a constant term or an x term. All right, so I would start off by doing row 2 minus row 3. Row 2 minus row 3. Again, why are you doing row 2 minus row 3? Could I do it the other way around? Absolutely. Okay, so there's multiple ways of arriving at the same solution, but long as your final answer is in row echelon form. Okay, so again, you could do row 3 minus row 2 if you wanted, but I'm just doing row 2 minus row 3. Okay, so I'm going to replace that new result in row 3. So this guy right here is x minus 2y minus 3z is equal to 2. And let's do some math here. X minus x is 0. Negative 2y minus y is negative 3y. Negative 3z minus negative z, which is negative 3z plus z, is negative 2z. And 2 minus negative 1, of course, is just 3. Okay, so if you're doing these problems for the first time and you have no idea how to begin, I would work my way from the bottom up. Okay, so take that third row and try to get z by itself. take that second equation or that second row and try to get it such that you have y plus z is equal to constant, and then just keep that first row with all the constants, x, y, and z's constants, and the constant column all available. Okay, so you'll kind of see as I finish this problem here. All right, so I have row 2 minus row 3, right? And the next thing I want to do, right, is to get rid of that x somehow. And the way I'm going to get rid of the x, right, is to multiply equation number 2 by -2. So -2, row 2, and add it to row number 1. So over here, I'm going to have 2x plus 4y plus z is equal to 1. And I'm going to do some math here. -2 times x is -2x, -2x plus 2x is 0x. -2 times -2y is 4y. 4y plus 4y is 8y. -2 times -3z is positive 6z. Positive 6z plus 7. Oh, sorry, positive 6z plus 1z is 7z. And -2 times 2 is -4. -4 plus 1 is -3. Okay, and then just bring down that first equation, or sorry, that third equation. Okay, so slowly but surely, right, my second equation in my second row has just y and z and -3. The last thing I need to do, right, is just basically get z by itself, and you can just do a little elimination between equation 2 and 3. And so this time you're going to have to multiply row 2 by a constant and row 3 by a constant, right? So the way I would do it is do 3 times row 2, right, plus 8 times row 3, and then replace that last equation by this result. All right, so lots of writing. 2x plus 4y plus z is equal to 1. I'm going to rewrite the second equation again. 8y plus 7z is equal to -3. And let's do the math here, right? 24 minus 24y is going to be 0y. 21y plus -16y. 21z plus -16z is positive 5z. And 3 times -3 is -9. -9 plus 24, right? 8 times 3 is 24, is just 15. Okay, so now we are in REF form. Okay, so just to review, right? Each leading coefficient has zeros below it. So 2 has zeros below it. 8 has zeros below it. Each leading coefficient, right, is to the right of the leading coefficient above. So this really applies to the 8y right here. 8 is to the right of 2. 5 is to the right of 8. Okay, and you're done. And basically, you just back solve from here. Okay, so clearly, right, you can solve. You get z is equal to 3. And then substitute, right, 8y plus 7 times 3 is equal to -3. You're going to get 8y is equal to -3 minus 21. 8y is equal to -24. Y is equal to -3. And then plug back everything back into the first equation. Okay, so 2x plus 4 times y plus 3 is equal to 1. You're going to get 2x is 2x minus 12 plus 3 is equal to 1. 2x is equal to 10, and x is equal to 5. Okay, so final answer, you can write it as an ordered triplet, 5, -3, and 3. So the question, again, is, Mrs. Zhu, do I have to put it in this row echelon form? Do I have to notate it like you did? Can't I just get the final answer because I learned this in Math 3 last year? And the answer is no. You have to put it in row echelon form. You have to notate it like I did over here, okay? Because the directions say specifically to use Gaussian elimination, which means switch rows, multiply rows by constant, and the final form must be in row echelon form, okay? So if it just says solve the system using any technique, then by all means, right, what you learned in the past, you can apply. But the whole point is, to notate and to, use this new particular method and to put it